So for the first question, my final answer comes out to be -5 radical 3 plus 20 radical 2. Again, they cannot be combined any further. It can't be simplified anymore because the numbers inside the radicals are not the same. You have to have like radicals in order to combine. Okay, thank you, Angela. I see you sent me a text. Okay, so let's look at the second question. The second question, this was in adding and subtracting, this is a multiplying. And when we multiply radicals, we have to remember that what we do is, you don't have to have the same number inside the radical, but what you have to do is multiply the numbers outside together. 4 times 2 is 8. And the numbers inside together. The 6 times the 15 happens to be 90. Don't multiply a number outside a radical with a number inside. Notice these are each monomials. They're single terms because there's nothing here except multiplication. Of course, in the end, you'd like to try and simplify your radical, and the square root of 90 actually can be broken up into the square root of 9 times the square root of 10. Remember, when you're breaking it up, you need one of your numbers to be a perfect square. If you have 2 choices for numbers of a perfect square, you want to pick the larger perfect square. So the number left inside the radical is not so big. But 90 only has a choice of 9 and 10. The square root of 90 is plain 3. So now I take the 8 that's on the outside and multiply it by the 3, which gives me 24 square root of 10. And that would be your answer in simplest form. Again, they usually want your answers in simple form. Sometimes they don't even say combine or multiply or add or subtract. They just say simplify. And they want you to simplify everything and get things as combined as possible. Again, sometimes you get more than one term because you don't have like radicals. Okay, so that's where we had left off on Tuesday. So I want to continue with our discussion of multiplying and then go on. If we know how to add, subtract, and multiply, of course, the next thing is how do we divide polynomials. Okay. So sometimes we have a situation where we want to multiply, let's say, 2. This is not. Again, I don't know, might be this eraser. Suppose I have something like this. 2 radical 5 times 3 radical 15 minus 7 radical 2. On the way. I'm just having trouble with my marker. Okay, big word. In other words, We have a monomial on the outside. The 2 radical 5, that's one term because everything's connected by multiplication. And we have 2 terms on the inside the parentheses. We have the 3 radical 15 minus 7 radical 2. And these 2, I mean, the first thing would be try to simplify the number, see if you could combine what the radicals, but you can't because you can't simplify 15. The only thing 15 becomes is 5 and 3. And the 2, and neither of those are perfect square, and 2 is just as simple as you can get. So we have to remember what we do whenever we multiply a monomial by a bi or trinomial or polynomial. We have to use the distributive property. In other words, I have to multiply the 2 radical 5 times 3 radical 15, which will give me 6 radical, well, 5 times 15 is 75. And then we have to do the 2 radical 5 times the negative 7 radical 2, which will give me negative 14 radical 10. Notice, I multiply the numbers outside together, the numbers inside together. And I had to do it twice because I'm multiplying a monomial by a binomial. Of course, now I want to try and simplify. Well, the square root of 75, I could break up into 25 and 3, because 25 times 3 is 75. And the square root of 25, it's a perfect square, which is 5. So now I take my 6 and multiply it by this 5, which gives me 30 radical 3. And then I go to my next term. Now, the only thing 10 breaks up into is 5 and 2. Neither of those is a perfect square. So I can't simplify. Not everything can be simplified. So I just bring this down. And my final answer becomes 30 radical 3 minus 14 radical 10. And that's my final answer. So if I have a monomial times a polynomial, I just use my distributive property and multiply term by term by term. So then what happens if I have a polynomial times a polynomial? What if I had 2 binomials that I wanted to multiply? Let's say I gave you this problem. Suppose I gave you 5 minus radical 2 times 3 plus 4 radical 2. Suppose I want to multiply a binomial by a binomial with radicals. Well, we know how to multiply binomials. In order to multiply binomials, we use our process that's called FOIL. First, outer, inner, last. Basically, we use the distributive property twice. We first multiply everything by the 5, and then we go back and multiply everything by the radical 2, and then combine any like terms that we have. So let's do that first. We have the first terms are a 5 and a 3. So 5 times 3 is 15. Okay, now we're at outer. That means the 5 and the 4 radical 2. We're multiplying this is a positive 5 and a positive 4 net radical 2. Now remember our basic rules. Numbers outside of radicals, if they're not inside a radical, you can only multiply it with a number that's outside a radical. If it's inside the square root, you can only multiply it with a number that's inside the square root. So this 5 is not in any square root, so we can multiply it by the 4 because that's outside. That'll give me 20. And since there's nothing where this is really like a 1 times radical 2, that'll just give me radical 2. That's outer. Now we're at inner. Inner, we have a negative radical 2 times a positive 3. Well, a negative times a positive is certainly negative. And the number outside here is obviously a 1, so it's a 3 times a 1, which is just 3 radical 2. And finally, we're at last. We have negative radical 2 times 4, positive 4 radical 2. So the outside numbers are a negative 1 and a positive 4, which will give me a negative 4. And the radical 2 times the radical 2, we multiply those together and we get radical 4. And I just want to make a comment. Well, let me finish this and then I'll make my comment. This, as soon as I see square root of 4, I know I can simplify it because 4 is a perfect square. This square root of 4 is just a plain 2. So this becomes negative 4 times positive 2, which is negative 8. And after I simplify that, I can see that my like terms are the positive 15 and the negative 8. They don't have any radicals next to them. They're just regular numbers. They can be combined. 15 minus 8 gives me 7. And the 20 radical 2 minus the 3 radical 2 are like radicals because they're the same number inside the radical. So all I have to do is 20 minus 3, which is 17. And my answer becomes 7 plus 17 radical 2. Now don't combine this 7 with this 17. This is like having a plain 7 with a 17x. They are not like terms. The only thing you can combine are when you have things that have a radical 2 next to them. I know it looks enticing to do, oh, the 7 and 17, why can't we add them? We can't because they're not like terms. This is my answer in simplest form. And if I look at this, I want to make a comment about what I did before. When I was doing the last, I had negative square root of 2 times 4 radical 2. That's what I did for the last. And obviously the outside numbers were the negative 1 times the 4, which is a negative 4. And the radical 2 times the radical 2 came out to be radical 4, because 2 times 2 is 4. But obviously square root of 4 is 2. Anytime you have something of the nature where you're multiplying the square root of x times the square root of x, no matter what the x is, if you're multiplying a number by itself, what you're going to get is the square root of x squared, which is just going to be x. In other words, when I multiply the square root of 2 times the square root of 2, I don't have to go to the square root of 4. I can immediately in my head say square root of 2 times square root of 2 is 2 without a square root. So this would just give me negative 4 times 2, which again would give me the negative 8. It's just obviously I'm getting the same answer. It's just a little quicker. We'd like to do these things as quickly as possible. And this is one shortcut we can always take. Whenever we have a square root multiplied by itself, as long as it's the same number and the same exact number, the square root of 2020 times the square root of 2020 is just the 2020. I don't have to actually do the multiplication, because when you're multiplying a radical by itself, you just get the number that's inside the radical. Now, let's see if you really understood what we were doing. Let's see if I can give you a problem and see if you could come up with the answer in simplest form. Okay, what if I gave you this? I want you to do 3 radical 5 minus 7 squared. I want you to take the binomial 3 radical 5 minus 7 and square it, which means multiply it by itself. I'll start you off on that. You have to rewrite this as 3 radical 5 minus 7 times 3 radical 5 minus 7. While you are doing this, I'm going to take attendance. Jesus, Antonio, Jesus. Jackson Avila. Good morning. Tiffany. Hi, good morning. Kayla Brantley. Kayla Brantley. Tashana Caesar. Good morning. Yeah, I know you're here because we talked before. Wensley Charlemagne. Wensley. Tatiana Collins. Tatiana. Awa Diallo. Good morning. Ashay Douglas. Ashay. Eliana Estee. Good morning. Emily Gomez. Emily. Anastasia Guerra. Zenabu Hamed. Zenabu. Good morning. Ismail.
Good morning.
Good morning. Nice to hear your voice. One of my people I can always count on. Jaden Jackson.
I'm
Jaden.
here.
Hi.
I'm here.
Good morning. Ashiana Jacobs. Ashiana. Anijah John. Thomas John.
I'm here.
Hi, good morning.
Morning.
You're not related to Anijah, are you?
No.
It's too common a name to, okay.
Yeah.
I thought there's no off chance. I've taught twins, so it's okay. Paul LeBrun.
Here.
Hi, good morning.
Morning.
Ashley Moorhead. Ashley. Angelica, I know you're here, you answer the question. Tayon, I also know, Tayon, you're here, I know also. Good morning. And Akeem Richards. Craig Ricketts. Craig. Giovanni Rowe. Good morning, Giovanni. Devon Lee St. Jules. Najee Waddell. Okay. Tatiana. Okay. I think we're, okay, so let's try this problem now. Again, we're going to have to use FOIL because this is two binomials. Again, I know they're binomials because between the two things, there's either a plus or a minus. This 3 radical 5 is a monomial because there's nothing in between the numbers. But once there's a plus or a minus in between the numbers, then you get another term. Okay, so we have to use FOIL. So we're going to go first. 3 radical 5 times 3 radical 5. So 3 times 3 will give us the 9. Those are numbers outside. And the square root of 5 times the square root of 5 is obviously the square root of 25, which is just 5. But I could have said that right away. Whenever I'm multiplying a number by itself, radical 5 times radical 5, 2 radicals, the same exact number, it just gets rid of the radicals. That is just plain 5. No longer in the radical. So this first term turns out to be 9 times 5, which is just plain 45. There are no radicals there. Okay, now I go to outer. That's 3 radical 5 times negative 7. So I multiply the 3 and the negative 7, which is negative 21, and I just bring along the radical 5. That's my outer. My inner is the same. It's again a negative 7 times the 3 radical 5, which again is a negative 21 radical 5. And finally, the last is negative 7 times negative 7, so that's a positive 49. So here are my 4 terms, but I see I have like terms. The 45 and the 49 are just plain numbers without any radicals. Those can be combined. That gives me 94. And the negative 21 radical 5 and the negative 21 radical 5, those are like radicals because they're both attached to radical 5s. And the negative 21 minus 21 gives me negative 42. Remember, there are 2 negative numbers, you combine them, and your final answer, don't combine these because these are not like radicals, is 94 minus 42 radical 5. That would be your answer. Okay. Well, what happens what happens if we have something like this. I'm going to give you a very similar problem. Very similar problem. See, that was the problem. It was wet. What if I gave you something like this? 2 minus 3 radical 7 times 2 plus 3 radical 7. I'm going to give you a minute to try this on yourself. This is not a square because in one parentheses we have a minus and one we have a plus. So let's see if you can do that. Okay, let's work on this together. Again, it's 2 terms. This has a minus in between them, this has a plus. So let's do the FOIL. First, 2 times 2 is 4. Outer, the positive 2 times the 3 radical 7. So I multiply the 2 times the 3, those numbers are outside, that gives me 6, and I just bring the radical 7 along with it. Then I do the inner, negative 3 radical 7 times 2. So the negative 3 times the 2 is negative 6. And again, I just bring over the radical 7. And finally, I have a negative 3 radical 7 times a positive 3 negative 7, radical 7. So I multiply the negative 3 times the positive 3. The outer numbers are negative 9, positive times negative is negative. And radical 7 times radical 7, I can use my shortcut and just say 7. You could in your mind have said it's the square root of 49 and the square root of 49 is 7, but I'm doing it the shortcut method. Okay, so let's see what we have. First of all, this 9 and the 7 can be multiplied because there's no radicals here anymore. This is just minus 63. And I can add the 4 from the front with a negative 63. These are just plain regular rational numbers. They don't have any radicals next to them. 4 and negative 63 is negative 59. And then these are like radicals, 6 radical 7 and negative 6 radical 7. But when I add 6 and negative 6, I get 0. Remember, I'm combining them. And 0 times radical 7 is just 0. In other words, this just cancels out. And my final answer is negative 59. And I learned something from this as well. This type of binomials, we've had them before. We have the exact same binomial, except one has a plus in it and one has a minus in it. They're what we call conjugate binomials. Conjugate binomials are two binomials that if you look at them, look exactly the same, except for the sign in between them. In one case, you're going to have a plus, and one case you're going to have a minus. Something like could be a plus b times a minus b. It turns out, and we've mentioned this before, that when you have conjugate binomials and you're multiplying, you don't have to do the whole FOIL, because for sure the outer terms and the inner terms are going to cancel out because they're going to be the exact same expression, except one's going to have a plus in front of it and one's going to have a minus, which means, for example, if I multiplied a plus b times a minus b, I only have to do the a times the a, which is the a squared, and the b times the negative b, which is minus b squared, because the outer term would be negative ab, and the inner term would have been positive ab, and they cancel each other out. So anytime I know that I'm multiplying conjugate binomials, I can save myself time by just multiplying the first two numbers together. 2 times 2 is 4. And the second numbers together, -3 radical 7 times +3 radical 7, which gave us a -9 times 7, or -63. And my final answer comes out to be 4 minus 63, or -59. Anytime you're multiplying conjugate binomials with radicals, you don't end up with any radicals in your answer. Your answer comes out to be a plain, what we call rational number, a number without any square roots in it. And that's a very important thing to know, because again, it saves us time. And it's going to be very helpful in the next thing that we want to do. I'm going to go through 2 more types of problems, and then I'm going to give you a couple to try. We really know how to multiply now. We know how to add, we know how to subtract, we know how to multiply. Let's talk about dividing. And just like when we talked about multiplying, we first talked about multiplying monomials together, just one term by one term. Let's talk about dividing one term by one term. So let's say I had an example that looks like this. Let's first start with an example where we have a fraction. And we have a fraction in our radical, and we want to simplify it. So the first step you're always going to do is you're going to separate it. To have a fraction in a radical means that basically you have both the numerator, the 2, and the denominator in radicals. That is our first step. When we have a fraction, it really means separate it, put each in their own radicals. And when we're told to either divide or simplify fractions that have radicals, the main concern is the denominator. Now, this is just technical. This is what's meant when the term is said simplify. You want to make sure that you're not left with any square root in your denominator. So the question is, how do we do that? And we do it by a process that's called rationalizing the denominator. So the process we're learning now is called rationalizing the denominator. If it says divide, or if it says rationalize denominator, we are looking to get rid of the radical in the denominator. Well, the first thing you want to do, again, you work with the denominator first, worry about the numerator at the end, is you try and simplify that denominator. And of course, we can simplify the square root of 27 into the square root of 9 and the square root of 3, because 9 times 3 gives us 27, and the square root of 9 is 3. So we're left with radical 2 over 3 radical 3. So we started on this process. We now don't have this larger number in the radical, but we still have a square root in the denominator. So if your denominator is a single term, which we have right here, we'll worry about binomials in a minute, but if your denominator is a single term, then just multiply the top and the bottom, the numerator and the denominator, by the number inside the radical. In other words, the number inside the radical here is 3. Multiply top and bottom by radical 3. We know when we're multiplying a fraction, you don't change the value of the fraction. We just did a whole thing on fractions. As long as you multiply both the numerator and the denominator by the same thing. Now, why would I have done that? Because I know when I multiply the square root of 3 times the square root of 3, anytime I multiply a radical by itself, it just gives me the number that's inside the radical. Or we could think square root of 3 times square root of 3 is square root of 9, which is 3, not in a radical. So therefore, my denominator turns out to be 3 times 3, or just plain 9. What about the numerator? Well, I have to multiply the radical 2 times the radical 3. Those are both numbers inside radicals, so they can multiply together, and that gives me radical 6. And my final step is to see, can I simplify this radical 6? And no, the answer is not. There's nothing I can break it up to. I also can't reduce this because this 9 is outside a radical and this 6 is inside a radical. Just like with multiplication, you can only multiply outsides by outsides and insides by insides. The same thing is true with division or fractions. You can only divide outsides by outsides and insides by insides. Since the 6 is inside the radical and the 9 is outside, I can't do anything further. And this is what's called simplifying. Again, sometimes the answer doesn't look simpler than what you started out with. But as long as there's no radical in the denominator, that is what's called simplification. Let me see if I can give you a problem to try. Very system for you one to try. Suppose I gave you this example, the square root of 4/3. Let's see if you can simplify this as much as you possibly can. Again, by rationalizing the denominator. Okay, I think we can do this together now. See anybody having? I'm gonna do what I did before. It's a fraction inside a radical, so I'm gonna separate it. I'm gonna put the radical 4 on top and the radical 3 on the bottom. Now, right away, I notice that the top, the square root of 4, is a perfect square. I could really write that as 2 over radical 3. You didn't have to do it this way, but I just noticed. Square root of 4. 4 is a perfect square, so the square root of 4 is just plain 2. We may as well just simplify it. Okay, now but that does not take care of everything. Because what I still have, even though it looks pretty simple, but what I have is a radical in the denominator. I have 2 over radical 3. When it says simplify, I cannot leave a radical in the denominator. I have to rationalize the denominator. Now, I can't simplify this square root of 3 by anything, but I do what I did before. I multiply the top and the bottom by the square root of 3. If you notice, before we only multiplied by the square root of 3. If this would have been 5 square root of 3, I wouldn't have to multiply by 5 square root of 3. I just multiply by the square root of 3. Because when I multiply the square root of 3 times the square root of 3, that gives me the rational number plane 3. And my final answer comes out to be 2 radical 3 over 3. And you may say that, again, this doesn't look so simple, but what we've accomplished is we have the smallest number we can possibly have in the radical. We can't simplify that anymore, and we don't have any radicals in the denominator. And that's what, when the term simplify is used, that's what you want to do. Okay, Angelica, do you see why your answer is not completely correct? Okay, because you left it with the radical in the denominator. Okay, so now let's go on to our next type of question. We know how to deal with a fraction.
Excuse me. Yes. Hi, I have a quick question. So it doesn't matter if the numerator has a square, like a square root, but if in the denominator, it cannot have one?
Perfectly. Thank you for emphasizing it. When you're simplifying, it doesn't matter if there's a radical in the numerator. What we're concentrating on, what we don't want to be left with, is a square root in the denominator. Notice, before I did that, I had the 2 alone in the numerator and the square root of 3 in the denominator. And I actually, by working this out, I ended up with a radical in the numerator, but that's fine. It has to do with when you're adding fractions. If you had to add these fractions, you'd have to have a common denominator. And it's very hard to find a common denominator with a radical in it. So when we say simplify, then every textbook does this. This is across the board. Even if it goes against your grade and you think, oh, it looked simpler before, when the term simplify is used, it means concentrate on your denominator on the bottom and make sure there's no radical there. Thank you for emphasizing that for me. Okay, now let's look at an example in which we have a radical in the denominator again. But my denominator is not just a single term, it's a binomial. How do we handle radicals in the denominator? In other words, suppose I had something like this, 2 over 1 minus radical 5. Again, I have a fraction. And in my denominator of my fraction, I have 2 terms. One of them has a radical in it. Could be both of them have radicals, but it's 2 terms. It's not a monomial. And we want to, again, rationalize that denominator. We want to make sure that we have no radicals in the denominator. Now, just listen to me now and don't take notes on this. I know your first reaction is going to be, well, I have a square root of 5. When we had a square root of 5, let's say before in the denominator, we just multiplied the square root of 5, top and bottom. I'm going to show you why this is not going to work. Why is it not going to work? Forget about the top. We don't care about the top. Look at the bottom. Look at the denominator. This is a binomial. We're multiplying by a monomial. So I have to use the distributive property. I have to multiply the square root of 5 times 1, which will give me the square root of 5. And then negative the square root of 5 times positive square root of 5. Well, square root of 5 times square root of 5 just gives me plain 5. So that gives me minus 5. And I can't even combine these because this has a radical and this doesn't. They're not like radicals. They cannot be combined. And by multiplying the denominator by the square root of 5, I didn't rationalize my denominator. I didn't get rid of the radical. So obviously this is not the right way to go. That's why I told you don't listen. Just listen, don't write this down, because this is wrong. So this doesn't work. So the question is, what will work? And I'm going to remind you that just before we talked about multiplying what we call conjugate binomials. And when we have conjugate binomials with radicals in them, we saw when we multiplied, it was a very quick multiplication because we only have to do first and last because they're conjugates. And the final answer didn't have any radical in it. So that's what I'm going to do. When I see that my denominator is a binomial that has a radical in it, what I do is I look for the conjugate of that binomial. Remember, I'm concentrating on the denominator. And the conjugate of 1 minus radical 5 is 1 plus radical 5. It's the identical binomial with the opposite sign. Of course, whatever I do in the denominator, I have to do the exact same thing in the numerator. So I decide to multiply by the conjugate. How do I go about doing that? Well, I'm gonna do the denominator first. Because when they're conjugate binomials, all I have to do is multiply first. 1 times 1, which is going to give me 1. And last, negative radical 5 times positive radical 5, which is just minus 5. No radicals anymore, because radical 5 times radical 5 is just plain 5. Which of course then gives me 1 minus 5 in the denominator, which is negative 4. What is the numerator? Well, there are 2 ways I can write the numerator. I could write it as 2 parentheses 1 radical 5. Or I could use distributive property. Actually, this is better, not to just to write it the outside times the inside, because then I can see if I can reduce. And I see that the top and the bottom can be divided by negative 2. Now, the reason I'm using a negative 2 is because I don't like a negative in the denominator. So dividing negative 4 by negative 2 will give me 2. Dividing 2 by negative 2 will give me negative 1. And my final answer then will be negative 1 times 1 plus radical 5 all over 2. Or if you wanted to, you could now distribute this negative 1 and get negative 1 minus radical 5 all over 2. But notice what I've done. I started out with something with a radical in the denominator, but I know my numerator now looks much more complicated, but I have rationalized the denominator. I made sure that my denominator doesn't have any square roots in it. Okay, I'm going to give you one to try now on your own. Let me see. I can do one. Okay, here's something. Suppose I give you this 7 over 9 minus radical 7. See if you can simplify this or rationalize the denominator, whichever way you want to look at that. Okay, I see we have an answer. Let's see if it's right. Okay, so if I do what I said I was going to do before, I look at my denominator and I see my denominator has two terms because there's a minus between the number and the radical 7. So I know I have to multiply by the conjugate. The conjugate of 9 minus radical 7 is 9 plus radical 7. So I'm going to have to multiply both the numerator and the denominator by the 9 plus radical 7. Again, whatever binomial is here, I do the same thing over here with the sign switched. I don't use the same sign, I use the opposite sign so that they are conjugates. Now I like to start with the denominators, and I have 9 times 9, which is 81. And then I have negative radical 7 times positive radical 7, which is negative 7. The radical 7 times the radical 7 is just 0.7. The negative times the positive is negative. So now I have to do 81 minus 7, and that gives me 74. My denominator is going to turn out to be 74, which is a rational number, so that's good. We now have to see what's going to happen with the numerator. Well, there are two ways of writing the numerator. One way is to write it with just leave it the way it is. 9 parentheses, 7 parentheses 9 plus radical 7. Or alternatively, both of these are perfectly correct, is to remove the parentheses in the numerator. Notice nothing can be canceled out. This 7 can't cancel out into that 74. So I just do 7 times 9, which is 63, at plus 7 radical 7 all over 74. On a final where it's going to be a multiple choice test, they might give you this as the answer, or they might give you this. They won't give you both because they're both correct. So you have to know that they're equivalent answers, and you can use either this answer or that answer. Which is, Angelica, yes, thank you. That's perfect. Also, what was I going to say? So we have to be able to either use one or the other answer. They're both correct. But again, the whole point is to get the denominator without any radical in it. It's called rationalizing the denominator. Okay, I just want to spend a few more minutes today. And don't forget to look for Delta Math homework. I already put in homework from Tuesday, but I'm going to put in homework from today as well. Please make sure you're keeping current with your Delta Math homework. It is a major portion of your final grade. Again, once we finish this chapter, I'm going to give you a test on, the next test is going to be on Delta Math. I like to alternate them. We had one test on Delta Math. We had a test in the midterm on Blackboard. So let's go back to Delta Math. In Delta Math, if you gave this answer or this answer, they would probably accept both of them as correct. So now we know how to add, subtract, multiply, and divide radicals, square roots. Again, we didn't really do too much with higher roots. That's not pretty much the focus of this course. And basically, when they want to say divide radicals, they really want you to rationalize the denominator. That's what you want to do. You want to end up without any radical in your denominator. So if we know how to add, subtract, multiply, and divide, the next thing we want to do is, let's see if we can solve equations that have radicals in it. And that's a major focus here. We keep doing this. When we talked about fractions, after we knew how to work with the fractions, we talked about solving the equations with the fractions. So we want to now solve equations that have radicals in it. And I'm going to start with a very simple one, because I think if I start with a simple one, you'll be able to understand what the answer is, and will come to an understanding of what method I should use to solve it. So let's start with something like this. Suppose I tell you I have an equation like this. The square root of x is equal to 9. I'm interested in finding out what x is. Well, let's think about it. Answer is not 3, because the square root of 3 is not 9. It's just the opposite. We are looking for a number that, when I take its square root, will give me 9. Well, I think everybody in their head could figure out that it should be 81, because the square root of 81 is 9. And basically, that gives us a method for solving it. Whenever we were trying to solve equations, we were always doing the opposite operation. If I had 3x equals 7, I saw the x's multiplied by 3. The opposite operation of multiplication is division. So then the first thing I did is I divided the 3x by 3 to get the x alone. Or if I had x plus 5 equals a number, then to undo that plus 5, we do the opposite operation, minus 5. Well, we're doing the same thing over here. Here I have the square root of x equals 9. I want to do the opposite operation of square root, and that's squaring, multiplying something by itself. And I know when I'm going to square both sides, when I multiply the square root of x times the square root of x, of course, that's just going to give me x. And on this side, I'm going to get 9 times 9, which is 81. And we always have to check these answers. Remember, we had to check answers that had denominators to make sure the denominator isn't 0. When we have radicals, we have to check the answers so that because we don't ever want to have a negative inside our radical. But here, if I check it, the square root of 81 is 9. It's perfect. That's the method. You have a radical, get rid of the radical by squaring both sides, because whatever you do to one side of the equation, you have to do the same thing to the other side. So let's say I had something that looks like this. Suppose I have the square root of 2y minus 1 plus 4 equals 7. Of course, it looks much more complicated, but the method, we really know the method. The first thing is you want to get your square root by itself. Remember when we had absolute value equations with those 2 lines next to them? The first thing is to get the absolute value by itself. The same thing over here. You want to get anything that's not in the square root to the other side, which means subtract 4 from both sides. And that'll give you the square root of 2y minus 1 equaling 7 minus 4, which is 3. And then we do what we just did before. We want to get rid of the radical, so we're going to multiply both sides by itself. We're going to square both sides. Now the question is, what happens when we square the square root of 2y minus 1? What happens when I multiply the square root of 2 minus 1 times the square root of 2 minus 1? Well, I know whenever I multiply a radical by itself, if the two radicals are identical, then I'm left with just what's inside the radical without that radical sign anymore. Multiplying this by itself, this radical 2y minus 1 times radical 2 minus 1 gives me 2 minus 1. That's the side. On the other side, I have a 3. Now, the 3 is not in a radical. So I can't say that my answer is going to be 3. Because now I actually have to multiply. 3 times 3 has to give me 9. So the easy part is what looks more complicated. This is so complicated looking, but by squaring it, all I'm doing is getting rid of this radical sign. I'm just left with what's inside the radical. The other side, whatever it is, it's not in a radical. It has to actually be multiplied. 3 times 3 has to give us 9. But now I have a very simple equation. I'm going to solve that by adding 1 to both sides. This will give me 2y equals 10. And of course, to solve that, I just divide by 2. And my final answer is 5. I must check. I must check. Check your answer. So this will be 2 times 5 minus 1 plus 4 equals 7. So 2 times 5 is 10 minus 1. This is the square root of 9. And we know what the square root of 9 is. That's 3. And 3 plus 4 equals 7. This does check. This is a good answer. Here's my answer. Basically, to solve a radical equation, we've got to square both sides. Okay, I'm going to end this class by having you do one, and we'll go over it, and then I'll let you go. So let's do equal. And on Tuesday, we'll do some that are a little bit more complicated than this. Let's do this. Let's see if you can solve this equation. The square root of 5x minus 7 plus 6 equals 5. Okay, I'm giving you a few minutes to try that on your own. Okay, I see that somebody has an answer already, so let's see if we can work on this together. To solve this, of course, I want to get the radical by itself. So I have to get rid of this 6. I'm going to subtract 6 from both sides. And that'll give me the square root of 5x minus 7 equals 5 minus negative 6. 5 minus 6, which is negative 1. And according to my rule, the next thing I want to do is to get rid of this radical by squaring both sides. And when we square the 5x minus square root of 5 minus x minus 7, multiplying it by itself will just give me the 5x minus 7. Squaring something with a radical just removes the radical. On the other side, when I square negative 1, negative 1 times negative 1 is 1. And now I have to bring the 7 to the other side. So that gives me 5x equals 8. And my final answer I got was 8 over 5. And we have to now check the answer.
Okay, I see what I make my mistake.
Okay, wait until you wait. Let me check. Let me check. Does everybody think that 8 over 5 is the right answer? Let's check. Remember I said if they have a radical in it, we've got to check it. Okay, so I'm going to have 5 times my x, which is 8 over 5, minus the 7, okay, plus 6 is going to give me 5. That's what I have to check. Well, let's see. When I multiply 5 times 8 over 5, remember, this is like a 5 over 1, and the 5's cancel out. So this just gives me 1 times 8, which is 8 minus 7. Let me just go over here. Let me move over here. So multiplying this canceled with this, or you could just do it. 5 times 8 is 40 divided by 5 is 8. 8 minus 7 plus 6 equals 5. Now, 8 minus 7 is 1. So this is the square root of 1 plus 6 will give me 5. Now, how much is the square root of 1? That's an easy one. The square root of 1 is 1 because 1 times 1 is 1. So I get 1 plus 6 equals 5. Is that correct? 1 plus 6 is 7. It doesn't equal 5. It's the wrong answer. I did everything right and I got a wrong answer. I got what's called an extraneous root. Remember that term? We used it before when we got a 0 in the denominator. Here, we get a 0 in the denominator, but we still got something. We got an answer that doesn't work. Let's see if we can retrace our steps and see what caused this problem. And I'm going to tell you it's right over here. When I did 5 minus 6 and I got negative 1, I got the square root of x minus 7 equaling negative 1. And if you recall, remember what I told you, whenever you have a radical sign, whenever you have a square root of a number, the answer is always positive. The square root of 36 is 6. It's not negative 6. You can't have the square root of something equaling a negative number. This is a false statement. Once I got to here, I knew I was going to have a problem. As soon as I get the square root of something being a negative number, I can stop right there. Don't get any further. There's no solution. Because what we noticed is that when we go ahead and solve it, you get something that doesn't make sense. The answer here is no solution. And this is something that they will try and trick you with. It looks like a regular equation, but as soon as you get a square root on one side and on the other side you get a negative number, it's like a absolute value always has to be positive. A square root also always has to be positive. So the answer here would have to be no solution. So this is something, and I don't let yourself get sucked into this type of a situation where, oh, I know the steps, so I'm just going to finish the steps. If you gave the answer to be 8/5, your answer is wrong. The answer here is no solution, which either you can write no solution or you can write that null set symbol, that symbol. Okay, everybody, have a nice weekend. I'm going to end just now. Again, there's going to be homework on Delta Math on this information. And we will
Okay.
continue with this next time. Bye-bye.
Have a good weekend, Professor.
Have a good weekend.
Bye-bye.
But